Welcome to How to Become a Production SQL Database Administrator. My name is Rafael. In continuing with the concept of indexes, we're going to go into a little more deeper concept and ask the question, when should indexes be considered and what factors influences the creation of indexes? Index is both an art and a science, so take that in consideration. And what I mean by that is obviously there are some scientific or technical reasons why you would create indexes, but once you understand the technical reasons, it becomes an art in the sense that it depends on the DBA and the person in charge in when and where and how to create indexes. And this is what the concept here is about. So when do you create an index on a table? We've already illustrated when the table is large in size, meaning the row count. These tables contain millions upon millions, if not hundreds of millions of rows. So this is one consideration you should take when contemplating an index. Now, as I mentioned, just because the size of the table, even if it has hundreds of millions of rows, is not necessarily the sole factor in creating an index. Other factors must be taken in consideration, and that is the frequency the table is used. So if you have a table that is got hundreds of millions of rows, but you're using it now and then it's kind of pointless to make an index on it. So again, that becomes a less of a science, but more of an art in the decision making. So the frequency of the utilization of a table is another factor that you should take in consideration. Now, obviously, you'll notice as we move along is when the columns are frequently used in the where clause. Now, obviously, as you know, the where clause is a filter, if you will. It navigates directly to the column that we're interested in filtering. So that's a great candidate of indexing. So whenever you have where clauses, and I'll be demonstrating that in a second, then that's a prime candidate for an index. So the query against the database has where clause. Columns that are frequently referenced by order by or group by are great candidates. So obviously if you're sorting the data and it's alphabetized, then that's obviously a very beneficial thing to have as an index. So that's another consideration that you may take in. Index should be created on columns with a high number of unique values. And what do I mean by that, by unique values? Well, create indexes on columns that are virtually unique, such as an integer. For example, if I create a clustered index on a primary key with an integer, then obviously that index is going to be created on the primary key, and it's going to be 1, 2, 3, 4, 5, and so on. So that's a very unique key. That's an integer. So that's a great candidate. And you should always create a primary key on a table so that you have indexing. And this is automatically created. And I may illustrate that in a second, but I think I've illustrated that before. Create a single index. Now this is important. Create a single index column where the where clause has a single column mention. Obviously, now the decision here becomes, should I make a single column index or a multiple column index when you're creating indexes? Well, the simple answer is that if the where clause has where last name equals XYZ, then obviously that's just a single column that you want to index. So there's no need to use multiple columns. However, if you're using select everything from table X where column 1 slash column 2 equals XYZ, then obviously in this case you're using multiple columns, so you may want to use that. So if the where clause has multiple columns, then create multiple indexes or multiple column indexes. So that's easier. Build indexes on columns with integer type, as I mentioned that. And the other reason we want to do that is because obviously integers take less space to store, which means faster returns. So that's an important concept. Now, the order of the composite index matters. So place the column in the index as is with the where clause. And what I mean by that is that if you have, and I'll illustrate that in a second, if you're indexing columns by last name / first name / social security number, and the where clause says last name, first name, social security, then your index should be in those three clauses also. Don't rearrange those where clause, and I'll illustrate that in a second. So use the column with the lowest cardinality first, and the column with the highest cardinality, which means keeping the unique values. That's all that means. Is cardinality means unique values. So if you had a choice between an integer or a last name, then obviously the cardinality of the integer is extremely low because you're not going to get any duplicates. Whereas if you were used the last name as an index, you may have duplicates. Therefore, the cardinality may be high. So a tough word to say. So make sure you understand that kind of concept. The bottom line where the art comes in for indexing is testing. Now, every scenario, every environment is different, and I can certainly give you the fundamental concept and some ideas of how to index in your environment. Well, ultimately, you'll have to test them to determine what best suits your environment. As I said, even if you have large amounts of data that are infrequently used, and there may be a scenario where you need to index that for future. So again, testing is the key in determining what will work in your environment. Play with the different types of combination of indexes. Check, and this is what we're going to do in a second. Illustrate, hey, I've got a table with 100 million rows. Should I need to index it or not? And if there's a lot of queries against that table, then obviously that's a candidate. Determine whether you need single or column. That obviously is determined by the query. If the query is only singling out in the where clause a single column, then there's no need to do multiple column or as it says, composite indexes. So these are the things that you have to consider, and in time, that's the time and testing, this will become easier to do. So these are some of the considerations you should take when you're creating an index, and these are some, certainly not all of them, but certainly a good representative of what you should and should not do. So now that you know what factors to influence when you're deciding upon creating or not creating an index, when should indexes be avoided? We're certainly by the opposite of this is a certainly good starting point, but let's just go over them. Again, as I mentioned, indexes should not be used on small tables, and I think I illustrated that in the previous video where I showed you, hey, if you can scan a few hundred rows quickly with your eyes and determine the last name that's requested, then there's no need to do that. It's better to do the whole table scan. So smaller tables do better with this table scan. Indexes should not be used on columns that contain a high number of values. So determine if using a select distinct, and determine if you have a lot of null values. If they do, that obviously is not a good candidate because you have to maintain the index on that. So the less maintenance on the index, the better for performance. Don't use an index and a high return of percentage of data. And what that means again is, for example, if I were to do a select against gender, and you only have a column with gender with F or M, and if I select everything for F, and if you got 1 billion rows, and if half the population is F, then you're going to get 500 million rows with F. So that's not a candidate. Ultimately, remember this: creating indexes come at a cost. Always remember that when you're looking at creating indexes. Indexes take up space, and that's an important consideration to take. And the other consideration is that when you do inserts, updates, deletes, and various operations, it becomes slower and slower since the database system not only needs to update the table that you're using these three keywords against, but also updates the indexes. And we've mentioned that also. So for non-clustered indexes and clustered indexes, anytime you do these kind of transactions or operations, it's affecting actually the index. And I'll be showing that in the next couple of videos. So these are some of the considerations you want to take in when you're deciding when and what factors influence. So let's jump into SQL and just see that in the real world. So one thing I want you to do, obviously, we've already created a database called SQL2, and I've got a table called people. And I just want you to note in the table people2 has been updated. I've updated to 100 million rows using the data generator. So I can't remember what I did for the previous ones. If I think it was 100 million, if I had, that's great. But if it didn't, so make sure you have about 100 million rows. Now you don't have to follow this necessarily because it is going to be taxing, but obviously for illustrative purposes, I can show it to you. So just to show that I do have 100 million rows, make sure in the right database, execute select count from people, and I should get 100 million rows. Now, this video is going to be a little longer because I'm going to be creating an index on 100 million rows. So that does take a few minutes. At that point, I'll pause the video and then we'll come back and continue with that. So as you can see, just the count of 100 million rows is taking a good 30-40 seconds. So continuing with it. So use the where clause for last name. Single column index would be beneficial if the table is used frequently, otherwise do not create an index. So everything we've been talking about here, now we're going to physically implement in a database so you get an idea of what's going on. So let's continue while that thing is going. So using the where clause without an index. Now I'm going to be running this script here. It's a select statement against the people table that has 100 million rows. And one thing to note is that I'm using the every single field. Note, while I'm using all the columns in a production environment, you only use the columns that are needed. And obviously course 1 illustrates that, which is learn TSQL. And I recommend you do that. So there's our answer. So now I'm going to highlight this and I'm going to run it, and this is going to take a minute. But before I do that, what I want you to look at, and don't worry about this next thing I'm going to show you. This is a little more advanced stuff in the performance issues. But if you highlight this, before I execute the query, which is going to take about a minute, 10 seconds at least as it did last time, I want to look at if it's doing a table scan. Right now, this table does not have an index of any type, and I can illustrate that here. If I go to people, index, refresh, you'll see that I don't have any index created. So right now it's going to do a table scan, even though it's got the where clause. So this select statement is saying, give me everything from the people table where last name equals Spence. Before I even execute that, I want to look at and show to you that it's actually doing a table scan. And the way you can do that is go right here, display estimated plan. Now, if you look at this, we're here, click on the icon that I just did, shows the table scan will be executed and missing non-clustered index is suggested for last name other name. The display estimated execution plan does not execute the query. It just shows you the plan if executed. So if I'd execute this, this is what I would have shown. So you can clearly see here that it's doing a table scan because it does not have an index. And you'll also notice that it's giving a recommendation to make a non-clustered index not only on the first name, but also other things. And actually, if we want to, I'm going to create that. So what I'm going to do from here is just go right click and go missing index detail, and it'll populate here. Now I've copy pasted that. So this is actually recommending what type of a non-clustered index would be beneficial to that script that we're going to execute. So what I'm going to do actually is, first of all, I'm going to run it without an index. So I'm going to run it, and it took about a minute, 10 seconds when I executed this. So now it's going through a table scan, as we demonstrated here, and it's going to go through the entire 100 million rows, and it's going to try to find the last name with Spence. And as you can see, it's already started. And I think the result set was in about 19 or 20,000. So while that is going, let's continue. So using the where clause without a non-clustered index, it takes about 10 minutes. And you can see, so it's going to take 10 minutes. And then what I'm going to do is I'm going to, after we've seen the demonstration here, I'm going to actually use the SQL's advice, if you will, and create a non-clustered index on last name. So it automatically detected that, hey, you're executing a query that has a where clause, and it recommends using a non-clustered index to improve performance. And we'll see that. Now, one thing I want you to note here also is that in this demonstration, it also gave you this, which I've commented out, which I don't want to do. So this I'm going to uncomment so you can see it. So right here, let me just switch here. And let me bring that out here. It's got multiple keyboards here. So let me look at this, and if I highlight, uncomment that, you'll notice that the recommendation was to include these columns, and it says include means include non-key columns. The key column is L name, but the non-key columns are all the other ones, and it's suggesting you should do that. Now, obviously, if I include that in my non-clustered index, this is called a covering index also, meaning it'll cover every single field that I had here. But again, note that while I'm using all columns in a production environment, you only use the columns that are needed. And I think I've mentioned that several times in previous videos. So this is why I don't want to include that at this point. So it took about a minute, 7 seconds, which we indicated. So now what we're going to do is I'm going to create a non-clustered index on last name, and I'm going to execute this. And obviously, as you can see, it took 5 minutes and 30 seconds to create that, because it has to create an index on last name and on the 100 million rows. So at this point, I'm going to pause the video, and when it comes back, we'll rerun this script here that we just ran and see if there's any difference having a non-clustered index. So I'll be back in 1 second. So let me pause, and I'll see you in a second. And we're back, and it did take about 5 minutes, so that's fine. So now, obviously, if you look at here, I ran the script again, and you'll notice it was a little better than before. It jumped about 20-25 seconds. So that's obviously it's using it, and we can verify that the index has been created if we refresh it and go here. So it's obviously created on the index. If I double-click it, you can see the GUI for that index. So it'll just take a second, and there we go. And obviously this is another way of creating it, but you'll see it's named. I didn't really name anything. It's a non-cluster index on the table that we spoke about, which is right here, which is last name. So let me cancel that. Now the other thing is, obviously, since it's already created an index in the back, it's taken up extra space. And if I ran this again, previously it took 51 seconds. If I run this again, it's going to take even a fraction of that second, because what we've called caching. And I don't want to get into caching that, but you'll see it still takes 4 seconds to return the same amount of data, which is almost 100,000 rows. And obviously now if I change the where clause to find something else, for example, Zuniga, obviously now that index is created, this should take a little faster also. So if I highlight that and execute it, and there we go, and that should only take a few seconds also, because it's now utilizing the index. And so that's another reason why you want advantages of indexing. And one thing you'll notice is that when I run these queries, and I run them again the second time, the same query, with the same results, is returning it in a fraction of a second, because the whole system is cached. And again, I don't want to get into that right now, but you'll see that even with using a different name, it is going to be a little faster. So remember, one thing to note is when I rerun the script, finding all the data name for the last name, remember, in a production server, don't use all the fields, only the ones that are needed. So that's very important. I'm just using it for demonstration purposes also, because I want it to take more longer than necessary. But if you go here without the columns, here I'm being selective, and I'm going to use only the people ID, first name, last name, as opposed to everything. And in this case, I'm going to use Spence. And you'll notice that since I've already got it clustered, non-clustered, it's going to be even faster. So if I highlight this and execute it, it should just take even a second. And it actually is just 1 second. Same thing with Zuniga. So let me comment this out, uncomment this. And again, since it's being cached in memory, then it's going rather even for the memory of this. And that's another subject we'll be talking about. But again, you see the benefits of creating an index and the advantages of creating a non-clustered index or a clustered index or a covered index. And the reasoning behind it, and I've given you right here, when and where and how the factors influence in creating indexes. So pay attention to some of these things are important. But a key thing is testing, testing, testing. Just because that recommendation gave me a recommendation on creating an index on every single field of the table, I may not select that. And this is where the art comes in. So you may want to test, include people ID, and that's it, and include first name, and see how fast it is. So you have to do a little work here on indexing. Indexing in itself is not really a difficult subject, but at the same time, it's not an easy subject to understand. There's a lot of it that goes on, and I've just touched basically the tip of the iceberg, if you will. So, but this will give you an illustration of the importance of indexing. In the next video, I'm going to show you now what happens to the indexing, the non-clustered indexing, the clustered indexing, when you start actually working with data and you're inserting data, deleting data, or updating data. What's happening to the index, and how beneficial or non-beneficial data is in dropping and recreating indexes. But that's going to be in the next video. So I'm going to leave it here. This is almost approaching 20 minutes. So I hope you got a understanding of clustered index, non-clustered index, and covered index. My name is Raphael, and this is how to become a production SQL database administrator. Thanks.